So hello students. Students, now we are going to start here. That is the integrals of some more types. Integrals of some more types. That means we will discuss here some special types of standard integral based on the same technique. That is the integrations by parts as we have done before. So let's see here how we can do it. This type of integrals, the special types of integrals. So integrals of some more types. That is the first question. Root x square minus a square is given here. So consider this one as let I is equal to integral root x square minus a square dx. So now students, what we can do it here? Generally integration by parts we will use here. So use it here 1 as this one. So now students, we will take it here this one as the first functions. Students, why we are taking this one as the first functions? Because we are not knowing the integral of these functions. That's why we are taking here as a first function, because we have to integrate of the second functions. And let's see here. So first function, and assume it here this one as the second functions. So product of two integrals, same formula. That is the first function, integral of the second functions minus whole. That is the integral differentiations of the first functions, integral of the second functions. Then again use the dx. So this one is the formula which we have to use it here. So first function, that is the root x square minus a square into integral of the second function. Second function is 1 and integral we are knowing how much we will get here. That is the x minus integral first differentiations. Students, dy dx root x square minus a square. So how much we will get here? 1 upon 2 root x square minus a square by doing the differentiation. 1 upon 2 root x square minus a square. But students, this one was not x. So again we have to differentiate this one. So integral differentiation of this x square, you will get how much? 2x. And differentiation of this one constant, that will give you 0. So differentiation is over now. So now again integral of the first functions, integral of the first function, second functions, integral of the second function is 1. It will give you x. So close the bracket and dx. So now these two and these two can be cancelled. So how much you get here? That is the root x square minus a square. This x we will write at this side. So minus. So these two and these two is cancelled. So how much we are getting here? X into x square. So integral x square upon root x square minus a square and dx. We have got this one. So now students, what we have to do it here? Again we are getting some complicated because we are not knowing the integral of this one. So we have to use it some techniques so that we can come out from these types of integral. So what we have to do it here? What we have to do it here? X root x square minus a square minus. So x square is here. So students, we can just subtract it a square in the numerators and add it a square by come out from this type of integral. So integral, that is the x square minus a square, and use it here plus a square upon root x square minus a square and dx. So now friends, we can use it this one as a bracket. So what this denominator will go along with this one, and second times will go along this part. So let's see here. So this one will be the remain same. That is the I is equal to x root x square minus a square and minus integral. So this one, how much you will get here? That is the 1 is here. So its power is 1 and its power is total 1 by 2. If you go in the numerator, so 1 minus 1 by 2, it will give you 1 by 2. And 1 by 2 can be written in the form of root. So root, how much? X square minus a square. So now this negative sign and this one is the positive sign. So by multiplication sign will be changed here. So minus you will get here. And a square is the constant, take it outside a square. So integral of this one 1 upon root, that is the x square minus a square dx. So now friends, what is the value of this one? Again we are getting the questions. So again we are getting the questions. That means we have taken this value as a I in the first one. So this value, this question total we have included as a I. So we can put it at this place, this I, and minus I bring it on LHS side. So I plus I, this one will give you 2I is equal to x root x square minus a square. So now students, minus a square is remaining here. So integral of 1 upon root x square minus a square. We have learned this formula before the exercise 7.6. So what was the formula? That was the log that is the x plus root x square minus a square, and use it here plus c. So now students, what we have to do it here? These two, it is in multiplication. We want the value of I. So these two, it should go in the division. So how much we get here? That is the, just by doing the division, so I is equal to how much you will get here? X by 2 root x square minus a square log a by 2, a square by 2, because these two will go the division of all the terms. So log, that is the x plus root x square minus a square, and use it one constant, that is the c. So student, this one is your new formula for the some special type of integral. So integral of root x square minus a square dx. So this one is your formula, x by 2 root x square minus a square by 2 log x plus root x square minus a square. So this one is your new formula which we have to use it for the exercise 7.7. Clear this one? So now let's see here in second part also. So first copy it this much, then we will continue the second part. So now students, let's see here second part, that is the integral of some more types. We will discuss here second one. So second one is here, that is the integral root x square plus a square. What is the difference between a? It is the negative, and now we have got some positive. So now let's see here this special type of integral. So again we will use the first function, this one as, because we are not knowing the integral of this one, that's why we are taking as a first function. So this one, consider this one as the second function. So same formula, first function, integral of second function, that is the x minus integral differentiation of first function, differentiation of first functions, you get here 1 upon 2 root x square plus a square. Differentiations, we are doing the differentiations, and this one was not x, so again we have to differentiate this one, consider as 2x, and differentiation of a square you will get the 0 because of constant. So now integral of the second function, you will get here x, and use the dx, and these two can be cancelled. So how much you will get here? I is equal to x root x square plus a square minus, that is the x into x, how much will get here? X square. So x square upon me root x square plus a square. So now students, what we have to do it here in this one, in this special case. So again we have to utilize here some techniques so that we can come out from this type of solutions. So use it here, positive sign is here. So use it here plus a square and minus a square. We can use it this one. So now this and this we will take it with the denominators of this term, and this one we will take with the denominators of a square. So let's see here. So x is equal to x root x square plus a square minus, just make the denominators of this term. So whole to the power 1 is here and whole to the power of this denominator 1 by 2. Just a to the power m upon a to the power n, it will give you a to the power m minus 1. Just we are using that one. So 1 and 1 minus 2, it will give you 1 upon me 2. So 1 upon me 2 can be written in the root also. So root x square plus a square. Now this one same thing we will write down with this term. So negative sign is here and constant is here. So we will use it this one as minus, and minus will give you plus a square and integral 1 upon me root x square plus a square dx. So now students, again we have got this one in the question number second was there, integral root x square plus a square dx. So integral root x square plus a square dx. So this one we have taken the I as a I. So total we have got what? I. So this one is the value of I. So negative I taken on the LHS side. So it will give you what? Plus I. So I plus I, it will give you 2I. And equal to x root x square plus a square. And this one was we have taken. And this portion is remaining here. So plus a square integral 1 upon me root that is the x square plus a square dx. So students, we have got this much. So now what we have to do it here, integral of this one, it will give you log, integral of this one, it will give you log x plus root x square plus a square. So we have to use it here. So 2i is equal to x root x square plus a square, x square plus a square and plus a square, and integral of this one, it will give you, that is the log in the bracket x plus root x square plus a square. You will get this much. So now friends, these two we have to bring it in the denominators. It will go in the division because we need the value of I. So I is equal to x by 2 root x square plus a square plus a square by 2 log, how much you will get here? That is in the bracket x plus root x square plus a square and plus c. So now students, we have got this much. So this much is the formula for this one. This is the formula for this one, second part. And now we will discuss what will be the formula of the third one. So now students, let's see here third one, that is I is equal to integral of root a square minus x square. So till now we have seen here root a square minus x square dx, we have seen this one, and second one root x square plus a square, we have seen this one. So now we will check it third one. So again we will use it here 1, integration by parts we will use it here. So first function, this one will be either second functions. So I is equal to, so first functions, that is the root a square minus x square. So integral of second function you will get x and minus integral first differentiation, how much you will get here, 1 by 2 root a square minus x square, this much. Differentiations of the, this one was not x, so again differentiate, this constant is 0, so differentiation of x square it will give you minus 2x, because minus x square is here, minus 2x. So now integral of the second functions it will give you x and dx. So x root a square minus x square, and minus it will become here plus, and these two can be cancelled. Integral x into x it will give you x square upon root a square minus x square. So now students, what we have to do it here? So one time we have to add it, and second time we have to subtract it. We have to arrange it in that form as we have arranged this question number first and second. So now a square minus x square we need here. So a square minus x square, this negative sign it can be changed from here, and this one negative sign x square plus a square, so minus a square we can arrange it here, dx. Numerical questions, a square minus a square will be cancelled, and x square minus x square and plus, what do you get here? Plus. Clear? This one. So we have arranged this one. So now this thing will go the denominators of whole to the power 1 as we have done as usual. So in the same way we have to write the denominators of a square also. So I is equal to x root a square minus x square minus, so how much will get here? So integral root a square minus x square, minus into minus it will give you plus a square, integral 1 upon root a square minus x square dx, you will get this much. So now students, what you have to do it here, again it is the I, so I value taken on this side, you will get 2i, so 2i is equal to x root a square minus x square and plus a square integral 1 upon root a square minus x square dx. So now integral of 1 upon root a square minus x square, students, it is the formula of sine inverse x by a. So use it that one. So 2i is equal to x root a square minus x square, a square minus x square and plus a square. So integral of this one, it will give you sine inverse x by a. This one is the formula. So we will use it this one. And now removing these two, it will go in the denominator. So I is equal to how much? X by 2 root a square minus x square plus a square by 2 sine inverse x by a and plus c. So this one is the formula for this integral, this particular integral. So clear, student? So now let's see here some questions by using this logic. So let's see here some questions of the exercise 7.7. So question number first. So student, let's see here question number 5, that is given here. Root this whole can be written here 2 square minus x square dx. So now we have to integrate this one with respect to x. So now students, it is in this form, that is the integral of root a square minus x square dx. That means third case as we have seen here. So case number third, what was there? Formula of this one. So 1 by 2 x root a square minus x square plus a square by 2 into sin inverse x by a. So this one is the formula for this one. That is the integral of root a square minus x square dx. It will be equal to 1 by 2x root a square minus x square plus a square by 2 root a square by 2, that is the sin inverse x by a. So this one is the formula as we have discussed in the third part. So now at the place of a, it is given here what? 2, and x will remain same. So we have to substitute the value at the place of a only 2, and rest of things will remain same. So how much will get the answers? So 1 by 2 x root a value is how much? 2. So you will get here 2 square and minus x square and plus a square, that means 2 square by 2 sin inverse x by 2. This much you will get here using one constant c. So now students, we have to solve it here. So 1 by 2 x root 2 square, you will get 4 minus x square plus 4 divided by 2, it will give you 2. So sin inverse x by 2 and plus c. So this much is the answer. So students, this exercise is totally based on these three formula only. You have to arrange it as in the formula, then put the value, that will be your answers. Clear? So let's see here one more questions. That is the question number second one. So second one we can write down in this form, that is the root 1 whole square minus 2x whole square. We can use it this logic and then we will integrate here. So how much will get here? That is the integral dx. So now students, what we have to do here, again we are getting in this same form, that was the root a square minus x square dx. What was the formula? 1 by 2 into x root a square minus x square plus a square by 2 into sin inverse x by a plus c. So we have to use it again this formula for the second one. So let's see here, that is integral. At the place of a square, we have to put it here 1 because 1 square is here. At the place of x, we have to put it here 2x. So how much will get the answer? Just directly. So 1 by 2 at the place of x, 2x root 1 minus 4x square you will get, and plus a square, that is 1 by 2 sin inverse at the place of x, how much? That is the 2x. So 2x by a, that is the 1, and use this one as constant. So it is in multiplication, 2 is the multiplication, it will go in the division. So 1 by 2 you will get more. So now we have to multiply that things. So how much you will get here? That is the 1 by 2. These 2 and these 2 can be cancelled. So how much you will get here? X root 1 minus 4x square and plus 1 by 4 sin inverse 2x plus this much is the answer. So clear students? So let's see. So students, as we have done the integral of this one, what is the coefficients of x? Coefficients of x is here 2. That 2 will go in the divisions. So 1 by 2 is here. So 2. This much is your answers. As we have done on this side, in the same way we have to do it on this side also. So now this one is your answer.